do for modeling with linear relationships. It is about continuous variables. So, what you would have noticed so far is we've done the simplex algorithm over and over again, but all of the solutions have been integers. All of the solutions have been whole numbers. So, 1 tin of Power Boost, or 2 tins of Super Health, okay? These scenarios have dealt with discrete variables, i.e. variables that have to take whole number values. Discrete variables are recognizable because it would not be appropriate to express them not as whole numbers. So would it be appropriate or acceptable for us to have a question that had 3.6 people? No, it's not realistic, depending on what country you're in, yeah? Or the number of eggs. I'm not going to get a partial egg. Okay? So all we've dealt with so far is discrete variables where it only makes sense that the numbers are whole. However, the variables do not always have to be whole numbers. For example, the number of litres. Do I always have to have full numbers of litres? No. Do I always have to have full numbers of kilograms? No. And are there different measures of cups? Can I get a half cup measure or a quarter cup measure? Variables like these can be expressed as fractions. For example, 1.25 litres, 3.45 kilos, 2.5 cups, etc. Variables like these are known as continuous variables. So, I'll give you a few minutes. Can you get these notes on how we deal with continuous variables with the simplex algorithm? Literally, your first step is to look at the question and can you check, does it make sense for the variables not to be whole numbers? If it's not number of people, if we're talking about kilograms or something, it might be that you're dealing with partial numbers. Okay? That's the first step. Step 2, nothing new. You just do the simplex algorithm again as normal. Step 3 is the hardest part of this. Because if your vertices are not whole numbers, are they going to sit on a grid line? No. So you can't just eye it off and go, oh, the coordinate is 3, 4. You can't do that because you don't know where it sits. It's somewhere in the middle. So how do we actually locate the vertices? To locate vertices that are uncertain, pair the lines and do a simultaneous equation. We did that at the start of the term. Okay? That's how you confirm where the coordinates are. And then lastly, step 5, when you do find the optimal solution, it is acceptable that they're not whole numbers. Can you get that down, please? And then we'll do an example. And then the rest of the double, you'll just keep it getting up to the end of 2D1 and making sure you've done the timeline up to that point. So I'm hoping it's become clear now why I told you needed to get good at the simplex algorithm, because that's all you've been doing since it was taught. Just slightly different things to think about. couple of minutes and I'll do the example. Oops, sorry. Just leave. If you have got those steps down, you might as well get the example. You have your translator. Yeah. Just get a photo of those steps. So that I can move on. Just get the. There's stuff in the rectangle. So just a quick overview, if you want it in a couple of sentences. What is different about dealing with continuous variables? When you look at the question, ask yourself, would it be reasonable for the answer to be not whole numbers? Do the simplex algorithm as normal, nothing different about that. But when you see that your lines are crossing, not on a grid line, sort of somewhere in the middle, like there, you can't use your eyes to determine what the coordinates are. So you need to do extra maths. You need to use simultaneous equations between the two lines that are intersecting there to check where they actually cross. Okay? So, let's look at these fertilizers. Fertilizers X and Y have ingredients A, B, and C in the quantities shown in the table in units per kilo. Fertilizer X costs $8. Fertilizer Y costs $12 per kilo. Farmer needs a mixture of fertilizers with at least 25 units of A, at least 38 units of B, at least 16 units of C. Let's highlight what's important. Is it important that it's $8 per kilo for X? Is it important that Y costs $12 per kilo? Farmer needs a mixture with at least. Is the at least important? At least 25 of A, at least 38 units of B, at least 16 units of C. Find the combo of fertilizers X and Y that I should use to minimize his costs and state that. How much would the farmer have to spend to satisfy his requirements if he could only use fertilizer? We'll get onto that. So can I ask you a couple of minutes to get that example down so that we can run through it together? Your first question, is it, when I read that, does it look like it might be possible to have not whole numbers? What is telling you in that question, what is telling you that it might not have to be whole numbers? The fact that it's kilograms. We're not talking about number of tins. We're not talking about number of bags, not number of people. It's the kilograms of something. Can you get that down, please, for the next couple of minutes? And then we've got the simplex algorithm to do. It's more risky when it's easier numbers. I get complacent. You're gonna be on the and then you was looking at me like, what the hell is it?
Look, I wouldn't judge.
No, I judge you people. That's what marking is. So you judge me just as good. if you do have the example down, start doing the simplex algorithm. Decide what the constraints are. Write the equations, draw them onto your grid. I'll still show the process. Remember, my process is slower because I'm talking you through it. A lot of you just sitting and waiting, so if you don't quite have it, can you get it from the person next to you? I've redrawn the table here because I had to go over the page. So, what were the constraints for ingredient A? What did I need to have at least of A? Good. So this is an example of doing the constraints. At least means what? Less than or equal to, or greater than or equal to? Well done. Were they all at least?
Yes.
Good. So B is going to be greater than or equal to 38 and greater than or equal to 16. I've also left a space in the table for the costs. 8 and 12, but the cost isn't a constraint. What am I trying to minimize or maximize here? Look at the question. What am I trying to minimize or maximize? Minimize the cost. So what's my objective function going to be? Which is?
A plus 12b.
What are the variables we use? X and Y? Yeah. You know what you were saying, but you just didn't say it, yeah? Now we did this table. What are the constraints for A? Read it vertically down. Someone else? Over there? What would my constraint for A be? So reading down there. 2x plus greater than or equal to? Greater than or equal to 25. Someone else, constraint for B. 5x plus 3y greater than or equal to 38. Last one. Yep. Why didn't he say 1? You don't need to. Well done. There's your constraints. There's your objective function. I'll do the working out for drawing lines. So drawing A, 2x plus 4 make y equals 0. 25, 2x is equal to 25. X is going to be 12 and a half, I believe. 4y is going to be 25. Y is going to be 25, 6 and a quarter. Now that you're seeing what these x and y intercepts are, is there a risk that your vertices are not going to be nice? That's A. Now let's look at B. 5x plus 3 lots of nothing equals 38. 5x equals 38. This one's going to be super dodgy. 38 divided by 5. 7.6. 3y is equal to 38. This is even more dodgy. 38 divided by 3. 12.67. And then C, drawing C. This one's the least dodgy, I reckon.
X equals 12. 3y equals 12. Y is going to be 4. So put little circles around.
It's 16.
16?
X is
Okay, cool. Thank you. Thank you. Yeah, where did I get the 12? Oh, I looked at cost. All right, go back. Thank you. So x is equal to 16. Y is going to be... Oh, so this one isn't... It's still dodgy. 16 divided by 3. 16 divided by 3. 5 and a third. 5.33. So put little circles around to help you draw. Get that working out done real quick. If you do have those locations down, start drawing the lines. Remember, I'm not going to get a microscope out and check that you put it at 7.6. It just has to look like it is. Has to be in the vicinity of it. Get the working out down, and also can you draw the constraint lines, please, like I've got there. 12.67. 12.67. 6.25. 4.67. 7.6. X 16. 5 and 30. Your graph of those lines should look like that. Can someone remind me what's worth marks on these? Is there something missing on the axes? What does the x... Yes, the labels. What does the x-axis represent in this context? How many kilograms of what? Fertilizer? Good. So, kg fertilizer x. So this one would be kg fertilizer y. Also worth marks is labels on the lines. So this one was 5.33 and x is 16. This one was x plus 3y is equal to 16, that line. This line is 7.6 and 12.67, so this one was the 5x plus 3y is equal to 38 line. And then the only unlabeled line is this one in the middle, which was 2x plus 4y equals 25. My little colouring arrows, if I said at least, what direction am I drawing? Down to the left or up to the right? Up to the right. So I need to colour a region that is up to the right of all of these lines. The only region that follows that, and also we can't forget that because these things have, kilograms have to exist. So what's a default constraint for that? X must be greater than or equal to 0. Y must be greater than or equal to 0. So my region that I'm talking about is up here. Okay? There are a couple of vertices that I can mark. This one, I know where it is. So I'm going to zoom in again so it's less. This vertex, I know where it is. It's at 0 and 12.67. So 0, 12.67. I'm going to erase that coloring because it's getting in the way. I know where that is. Do I know where this one is here? At the bottom? Yep, it's at 16.0. But this one here, question mark, that's where the new stuff is, okay? I don't know where that is. It looks like it's somewhere in the middle, but do you know for sure? Because your drawing might be slightly off. Because when you write a line, when you draw a line, does it go exactly where the ruler was? No, it goes slightly to the right of it because your pen or your pencil has thickness. So how do we work out where this is? Well, I do simultaneous equations for each pair of lines. So I'm going to do A and B. A versus B. What is the equation of A? How do I indicate simultaneous? Curly brackets. So 2x plus 4y is equal to 25. And B was 5x plus 3y equals 38. Someone remind me, how do I solve this by elimination? Any ideas? What do I look at? Are any of the coefficients the same size and opposite sign? No? I could look at the x one. Let's look at the x one. I want the coefficient of x to be the same size and opposite sign. What's the smallest number that 2 and 5 both go into? 10. So what could I times the top line by? So let's times the top by 5. What would I times the bottom by to get it 10 but negative? Times by negative 2. So the working out will transfer it over here. Your simultaneous equation is now going to be 10x plus 5 times 4, 20y equals 125. Negative 10x, take 6y, 76, I believe, negative 76. Then you add vertically. If I've got 10x, add negative 10x, how many x's will I have left? 0, 0x. If I've got 20y plus negative 6y, that's going to be 14y. And then, I'm not very good at subtraction. 125 take 76. No, slightly off, 49. 49 divided by 14. That tells me 3.5 for y. Am I done yet? Do I know the coordinates yet? I've only got the y coordinates, so I substitute that into the easier looking equation, which I believe is 2x plus 4y. So 2x plus 4 lots of 3.5 equals 25. 2x plus, what is 4 times 3.5? 14 equals 25. 2x is equal to 21. 11. X is going to be 5.5. That looks like it is, but what does it look like these? Do all three lines look like they're meeting in the middle somewhere? Well, we don't know. Maybe draw it better. It's intended to, okay? We've only checked one pairing. We've only checked A and B. What pairing could I do to check whether C is involved? It doesn't actually matter. You can check A and C or you can check B and C. So which one would you like to do? A and C? Verse them together and see what goes on. Okay? Just to double check, so we'll go A versus C. So we had A was 2x plus 4y is equal to 25. What is C? C is x plus 3y equals 16? Are any of the coefficients already the same? Same size, different sign? No, I have to do something. 2 is probably the best one. What could I times the bottom line by to make it the same size but opposite sign as 2? Good, times by -2. So working out goes here. I didn't do anything to the top line. 2x plus 4y equals 25. Negative 2x takes 6y equals negative 32. I can add vertically. If I've got 2 x's, but take 2 x's, I've got 0 x's. 4y takes 6y is negative 2y. 25 take 32, negative 7. What's the opposite of timesing by -2? Dividing, good. And if I divide a negative number by a negative number, what's the answer going to be? Positive. So y is going to be 3.5. Is that the same as it was last time? So it's probably confirming that all of these lines meet in the one place. But we're not done yet. I need to double check. Well, actually, what did we substitute last time? Did we substitute y is equal to 3.5 into a? So therefore, what can we confirm? Therefore, lines all intersect at 5.5, 3.5. So can I label this question mark now? Yeah. I used comma 3.5. Is that sort of what it looks like it is? Is it beyond 5 here on the x-axis? Is it beyond 3 on the y-axis? Right. That's the only difference with this. We needed to check where that was. What do you do now in the simplex algorithm? We draw up something that's got 2 columns. The objective function table. So I'll do it down here. Vertex / obj function. What were the vertices? We had 0 and 12.67. We had 5.5, 3.5, and we had 16, 0. What was the objective function? What were the costs of the fertilizer? Can someone remind me? I don't want to scroll up. 8x plus 12y. So the first one is going to be 8 times by 0 plus 12 times by 12.67. The second one is going to be 8 times by 5.5 plus 12 times by 3.5. And the last one's going to be 8 times by 16 plus 12 times by nothing. Calculator out. 12 times 12.67. The first one is $152.04. Oh, I don't want an updated calculator. 8 times by 5.5, 44. 44. I need to write that in my hand. Calculator doesn't do bed maths properly. 44. 12 times 3.5. 44 plus 42, 86 is the next price. Then the last one, 8 times by 16, 128. What were we trying to do in the question? Maximize cost or minimize cost? Minimize. So what was the lowest price in our simplex algorithm? 86. Put a star there. So therefore your answer to A is the optimal solution is 5.5 kilograms of X, 3.5 kilograms of Y at $86. Yes?
I don't believe that was what the question was asking. It was just asking for X and then
Okay. All right.
names for Y.
I quickly check. Find the combination of fertilizers X and Y the farmer should use.
I meant the first one and then the second one. Sorry.
I think I did. Didn't I just answer A?
Oh no, you did answer.
Yeah?
No,
I haven't answered B yet.
only saw B.
Yeah. So get that. Can you read out to me what B asked?
Oh yeah, I was just using only fertilizer X and only
Okay, we can answer B now. Which of these vertices is only using fertilizer X? Is it this one here, or is it the top one? The bottom one is fertilizer X only. And how much did that cost? Good. Fertilizer Y, if I use 12 2/3 of a kilo, how much is that costing? 152. I probably wouldn't choose that. It's too expensive, okay? So I'll do the answer to B here. B, was it one, that B1, was that the one asking about fertilizer X only? Yep. So using X only costs $128. 2, using Y only costs $152.04. That's that. That's the end of the topic. So your homework in now, to end of EX2D.1.